All right, thank you very much for coming this morning. Honestly, I was expecting everybody to be in the next room with Adam, especially after his talk in the keynote. But I guess you're here to hear all about tools, right? Let me just briefly introduce myself. I'm Jonathan. You've heard me in the keynote. I've been a .NET developer for, well, pretty much my whole career. And today I want to talk about all the new tools that are available with .NET Core. But before I do that, I wanted to quickly get a feel for the room. So who would call themselves .NET Framework developers? All right. There's one over there as well. Thanks. Who would call themselves .NET Core developers? Quite a few as well. Is everybody using Visual Studio or something else? Some are using something else than Visual Studio, right? I want to talk about tools, and there's a lot of tools with .NET Core, and a lot of changes as well in the tools. Like you don't need Visual Studio to do .NET development these days, and I'm going to talk you through a lot of them. And what I did is I made a couple of scenarios. So I want to start with just getting started with .NET, especially if you've never done any .NET development, or if you're on a Mac like me. How do you get started with .NET? Like if you have Visual Studio, you just install Visual Studio. You have .NET available on your machine. It even installs .NET Core. But what if you're on a Mac and you just want to, write some .NET code? How would you go about doing that? What are some of the tools that are available there? And then I want to talk about how we can improve our team workflow because of the new simplified project format. There's a new format for project files. It's much simpler than the old format used to be from the .NET Framework world. I'm sure with all the hands that a lot of people will remember that and what that looks like. And a lot of things have improved there as well. And I want to just show you what that means in terms of working together as a team on the same product or on the same code base. And then I want to make a switch to how would we go about documenting open source libraries or even shared libraries that you share within your own team. There are some new tools for that as well. And I wanted to show you how you can create interactive documentation for your open source libraries or shared libraries. Now I'll talk you through that. And then finally, last but not least, I would say, I want to show you some of the tools that are available for diagnosing performance issues with your applications when they're running in production. There are some new command line tools available that we can use to dive into what our application is doing when it's running in production. I want to talk you through those. So let me just get started with the first. I'm going to mostly do demos, so I don't have a lot of slides, only some slides to guide you through the narrative. So I want to start with how do we even get .NET? And once we have it, we can use the .NET CLI to build our applications, and I'm going to show you a couple of commands you can use to get started. And then there's one particular command I wanted to mention because I'm thinking that a lot of people, especially if you're from the Visual Studio world, you don't really know about this stuff, and I wanted to show you how that works. So with that, I'm going to start my first demo. So how do we get access to .NET? There's a new website which is called .net, which is easy to remember, and that will redirect you to a new website on the Microsoft.com website, basically. And from here, I can go to download, and as you can see here, we have Windows, Linux, Mac OS, all lined up, and it will automatically pick the one you're running on. Like I'm running on a Mac here, so I'll get the Mac OS downloads. And from here, I can just download the .NET Core SDK. And it's a package for macOS or an MSI for Windows or whatever is current on that platform. And you can just install it and you're all set up. And once I've done that, I have this new command line tool available, which is called .NET. And I have that here. Now, the important thing is that, can everybody see this, by the way? Is it visible for everyone? Right. So, there's an important concept that's different from when you're used to .NET Framework. If you have .NET Framework installed on your machine, there's only one version of .NET Framework installed on your machine. And you can only ever have one version. Well, you could have two, but basically you only have one. But with .NET Core, you can have multiple versions of .NET on your machine. And I can actually see the versions I have installed on my machine using a command called dotnet --info. And that will list all of the SDK versions that I have installed. So you can see I have a couple of 2.1 and 2.2 versions of .NET Core SDK installed on my machine. And it will also show me all the runtimes I have installed. Like the SDK and the runtimes, they are separate components. I can have different versions of the runtimes and different versions of the SDK installed on my machine. You can mix them and match them, which is pretty nice. So you don't have to worry when you install a new version of .NET Core on your machine that you're going to break all the apps that are already on your machine because of a new breaking change in the framework. The app itself will decide which version of the framework it's going to use and how it's going to, and that's the version it's going to run on. Now there is something related to patches, so if a patch version of the runtime comes out, it will try to roll forward to the latest patch version, because that's probably what you want because of security things and that stuff like that. But mostly it will just run on the version you specify with the app. So that's a very big difference with .NET Framework if you're used to that. Now, of course, this is all fine, but I wanna build apps. So how gonna do that? So I have this command called .NET new, which allows me to basically build a new project. And there's a whole bunch of templates that you get out of the box, like you have ASP.NET Core Web Apps, ASP.NET Core Web API, you have ASP.NET MVC, like all the things you know from .NET. And the nice thing is that you can actually extend these templates. So you can have additional templates. You can download them from the internet. There's a website. If you look at .NET new templates, you'll find it on GitHub. There's a site that lists all of the templates that are available. And some of the open source projects out there, like nService Bus, I'm not sure if you've heard of it, but it's a popular open source library. They even come with their own templates that you can install, and then you can quickly get up and running with that framework, basically, which is really nice. So with that, I can use .NET new, and I'm going to just do an MVC app. And I can specify the name of the project I want to put that in. So I'm going to say .NET Core Summer Event. It's going to create a new folder for me, and it's going to put some code in there. And we'll have a look at the code in a minute once this finishes. And it will do a .NET restore as well. So it will have all the NuGet packages you need to run this project. You have them on your machine installed. And it's taking longer than it usually does. Not sure why that is. Probably slow internet today. As always when there's a demo, right? There we go. So let's dive into that folder it created for me, and let's open up Visual Studio Code to have a look at the code that's in here. Anyone using Visual Studio Code? Oh, everybody. Well, almost everybody. If you're not using it yet, you should try it. It's awesome. I really love the experience you get with Visual Studio Code. It's not the same as Visual Studio, I'll tell you that, but it's different, but it's nice. Can everybody see this as well? Cool. So I have, basically what I get is I get a program CS, which is my main entry point for my application. And I have the startup class that allows me to configure my application, put stuff into the pipeline, all that stuff. And I have all the other things in here, like what you normally get with an ASP.NET applications, controller and some models and some views and so root with some CSS, JavaScript, all that kind of stuff. And it'll just scaffold that for me, which is nice. Now I'm going to open up a terminal here. And I'm going to go and do .NET run. This allows me to basically run my application on my local machine. These are really simple commands that you can really easily remember, I guess. Some do, if you do Docker as well, sometimes you get confused and you type docket or .NET or some combination of Docker and .NET, which is rather frustrating, but apart from that, it works. And it's really slow today, I don't know why. It's like really, really slow. By the way, while we're waiting for this to run, you see this .NET version here. That's actually useful if you do a lot of work on the command line. This is like this is the Z shell, which is a different shell than Bash, which you probably know. But this allows me to display the version of the .NET runtime that I'm using right now. So I actually know which version I'm going to use when I do the .NET commands. So now it's running, and I can go browse my application, and it's it's just a basic application, nothing special here. I can add some flags and do things like authentication. Like if you do in Visual Studio, you create a new project, they ask you what kind of authentication you want to use. I can do that here as well, just basically on the command line. So a lot of interesting stuff here. There's a lot of other stuff you can do. So let me just quickly show the commands that are available. So we can add packages or references to my project. I can do I can pack my project into NuGet packages. I can publish my project so I get all the output that I need to actually run it on some other machine. I can even build Visual Studio solution files using the command line. If you're working in a team with other team members that are using Visual Studio, this can be very useful. So there's a lot of other commands here. I won't go show you all of them because that would be boring, but just know that these are available. Now, the one thing I did want to show is the command called .NET Watch. Basically, what .NET Watch does, it's going to watch the files in your project, and when they change, it's going to stop the application that's running, it's going to recompile it, and then start it up again, which creates a really nice inner loop experience when you're developing your application. And you can use this both with running your application as well as your tests. So you just do .NET Watch run to run your application, and you can use .NET Watch test to run the test for your application. And when you make changes, your test will run again. Now I've made some changes here, and my application is running. So if I go here and I would say, this is not useful. I would just say like use authentication. I'm going to save. You notice here that it's saying, my project's not running anymore. It's rebuilding my project, and then it's starting up again. And this creates a real nice inner loop experience if you're doing development. There's a question? I don't think there is actually a way to do this in Visual Studio, but Visual Studio has a thing called Edit and Continue, which basically allows you to modify your code file. It will recompile it in memory, and then it will run again. So it's basically the same experience. It just works a little bit differently behind the scenes, but it mostly gives you the same thing. Obviously, if you're doing things like editing CSHTML, like the UI of your application, it will just, you won't need to recompile these because these are always recompiled on the fly. So, and the nice thing is that if I change this here, it will also not, it will not recompile. So it knows that the CSHTML file has changed, and it will just not show that. All right. So with that, any questions so far? Except for the one on Visual Studio. Anyone using the .NET CLI in their day-to-day development? Yeah, I find that I used to be a Visual Studio guy and do everything in Visual Studio, and I find that it's more the more I use the CLI, I kind of like it, and I'm mostly switching to using the CLI all the time, especially when you're on a Mac. It's useful. We will see Visual Studio though. So that's it for basically getting started. So let's have a look at how we can, work together as a team on the same project. So there's a new project file format, which basically makes it a lot easier to merge changes together if you're working on different teams. So that's nice. And another thing that helps there is the package reference, which is a new way of specifying your NuGet package dependencies instead of the packages config from before. And then there's the directory build props and directory build targets file that you can use, which makes it a lot easier as well. Let me show you what that looks like. I'm just going to turn on it's already on. That's interesting. And to show you that, I'm going to use Visual Studio. As I said, we're going to use Visual Studio. And it would be nice if this would actually respond. Not sure what's going on here. And it crashes, of course. That always happens when you're doing demos. So I have to reset this. That's great. So I'm going to skip that demo for now. I'll go back to the demo if I have time at the end, because my Windows needs to reboot. And that's going to take some time, unfortunately. So I'll just have to improvise, and I'll skip this part. I'll go back to it if I have the time, which I think I do. So keep that in mind. Sorry about that. I hope it's going to work in a second. So then, one of the things I wanted to show you is a new tool that's available. It's called try.net. And what it basically does is it allows you to write markdown files, which are like documentation. And you can combine that with a sample project for your library or thing you're gonna build. And you can write the markdown, and then it gives you an interactive experience with the code blocks that are in your markdown. And you can edit the C# that's in there, and it will get compiled, and then it will run, and you can see the output of what it's doing. So you can basically create interactive documentation for your project. And I think that's a really nice way for documenting, especially libraries, because you can really quickly show how that library works, what it does, and it allows you to do that in an interactive way as well. And I'm going to do a demo of that, of course. Now, the nice thing is that where's my terminal? Last Thursday, I think, they actually shipped a .NET new template, like the .NET new command I showed you earlier. And they shipped a new template that you can use to create these interactive documentation projects. So that got released last Thursday, and I was like, okay, am I going to put this in my demo? Because, you know, new bits and might not work, but it's working fine, so I'm going to use it. So what I'm going to do is I'm going to go out here and say .NET new, and I have to look up what the name of the template is. So it's called try.net tutorial. You need to install it using one of those NuGet packages. I'll share a link with some documentation on how it works. So I'm going to use that, and I'm going to say let's go to that folder, and I'm going to open up that in Visual Studio Code as well. And I'm going to talk you through what's in there. So basically, when we do this, we get a couple of things. We get a program.cs file. This is basically the entry point for your actual sample application that's somehow using your library, wherever that library may come from. It may be in the same solution or somewhere else. But it's this is actually what gets run when you run the sample from try.net. Then we also have a markdown file here, which is like a README, and this is just basically a sample. And you can see here that we have this code block, which is a code fence. If you've ever done markdown, you've probably seen this before. If you're not, this will basically render as just a bunch of C#. And it will do syntax highlighting and all that kind of stuff as well. Now, one thing you'll notice, there's no actual code in the code fence here, because what's happening here is it actually references the source file, the program.cs file that I showed you before. It's referencing the project that source file is part of. And then it's referencing a region. So if you've ever used regions in Visual Studio, I've heard people saying you shouldn't use regions because if you use regions, you have too large code files. That makes sense, but in this case, I think regions are coming back, and they're coming back for a good reason. So let's look at the program.cs file again, and you can see here that we have this region called Hello World, and that's between these region and end region tags. And this is actually the code that will show up in our interactive documentation. So I can change the code here, and I don't need to change the markdown file as well, right? So that makes sense. So let me just open up a terminal here and run a .NET try so we can actually see what that looks like. Now, one thing I need to change is I need to go in here, and I need to change this to, to 2.2. And the reason for that is that I don't have the 3.0 preview bits installed on my machine, because, you know, they're preview. You don't want to have preview bits installed on your machine. And I'll go into how I installed that for the next demo in a minute. So now it will compile against .NET Core 2.2, basically. And it should work. It doesn't always work the first time I try it, but here we go. So this is our basically our try.net, and this is the markdown file that I showed you earlier. That's what you're actually seeing here. And you can see that code block here. I can zoom in a little bit so you can see what's happening. So that's the code that was in the program CS file, right? And that's what you see here. Now let's do a run here. And usually this fails the first time, but it's working for the first time. That's great. So you can actually see the output of the application that's running here. And I can change this. I can say hello .NET Core summer event and run it again. And you can see that it's actually really running the code that I write here instead of the code that was in my program CS file, right? So that, to me, that feels a little bit like magic, but it's fun. It allows you to really do interactive documentation. You allow you to change your code. Now, one thing that I wanted to show you is how we can actually use this to document like a proper .NET library. So what I can do is I can do .NET add package, and I'm going to use this library called Figgle. I've probably never heard of it. I didn't until I looked for it. But Figgle is a library that allows you to basically write ASCII art. And you have different fonts that you can use, and it writes ASCII art to the console. And it's pretty cool. So what I can do is I can go to this program CS. Now, there's a couple of things here. As you can see, this is my main, and it's showing the region here. This is can you see it? Or all right. So it's actually passing in an argument called region, which was in the if you remember in the markdown file there was a section called region, and then in here it says if the region is hello world, it's going to run the function hello world within this application, and that function actually defined here, and it just says basically the console write line that we showed you earlier. So let's add a function here called Figgle. And let's do a region called Figgle. And let's do a console write line of Figgle fonts. This is the library that I just installed using .NET add package. I need to add a using, obviously. And then I can use a standard font. There's a standard font here. And I can say render. And then I can say like hello .NET Core summer event here, right? So it's basically the same as the hello world I showed you earlier, but now it's going to nicely render this into a nice ASCII art kind of thing. So now I need to, this is going to return int, so I'm going to return null, or 0, sorry. And then what I need to do here is I need to add this Figgle thing as an option here as well. Figgle. Now, behind the scenes, this is actually using a library called Dragon Fruit. I didn't think of the name. I don't know who thought of that name, but that's a new kind of experimental library from the .NET team for building command line APIs. So you can use it to build command line tools, basically. And it has some really nice features to make it really easy to parse command line arguments and then turn that into a function you run, and it's really nice. Definitely, if you're interested in building command line tools, you should check that out. And that's what it's using behind the scenes. So I've added that. So let's see what's happened. If I go to .NET try, run it again. And it's opening up my browser. Now, the one thing I didn't do is add this new section to my markdown file. So I need to edit the markdown file so I can actually reference that new region that I just wrote. So let's go to the markdown file. And let's do and basically I'm going to copy this. And I'm going to say use the region figgle. Now the nice thing is I don't need to recompile anything or do any kind of stuff. So I'm just going to refresh the page here. We can see the hello figgle coming up here. Now there is a green squiggly here. I'm not entirely sure why that is, but you know that's for some reason that's there. And let's now go and do run this, and we can actually see the ASCII art here. And what's really nice is I can actually go here and say do a dot, and it's actually showing me the IntelliSense as well, the same IntelliSense I had in my editor. Right, so I can actually show what the API looks like and show you how that works, which makes it really awesome. So if I go here and choose alpha, and I'm gonna go ahead. Now, one thing I did notice is that there's no way to resize the output window here. So I submitted an issue like, I think it was on first day, that there's no way to resize the output window, which would be nice in this particular situation. But maybe we shouldn't write that much output anyway, so I don't know. But I think this is a really nice way to really make interactive documentation for your libraries and to really show you how they can be used and what options are available and stuff like that. So I'm hoping that a lot of open source libraries will start to adopt this. I'm thinking maybe GitHub will do something like you can put this up on GitHub and it will work there as well. I don't know. They haven't said they will, but I hope they do. So you can actually do this straight on the README in the GitHub repo, for example. That would be really nice. Any questions on this? Yeah.
Can you also use it for learning, for instance, C#?
Yeah, that's a good question. Yeah. So the question is if you can use this to basically learn C# and do that. There's a website. If you, I'm not sure, but if you look for try .net, they have basically a version of the same thing that's running inside of the browser, and you can see it here. And so it's gonna take a minute to load, but this is basically the same thing, but it's entirely running inside of the browser, except for the compilation bit. I think that's doing somewhere else. I don't know how they do that, but this is actually entirely running in the browser. And there is they have quite a bit of documentation on getting started with C# as well, based on this. So much of the docs sites on Microsoft, like docs.microsoft.com, are starting to use try.net basically behind the scenes to make that all interactive, and you can start to learn C# and .NET and all that stuff. There are some samples for try.net as well you can try, which also contains a lot of the introduction to C# and stuff like that. Yeah. Any other questions? All right, thank you. Let's go back to my slides. Yeah, I think I showed you all of this. So the last thing, or perhaps not the last thing, I'm hoping my Windows works in a minute. But one thing I did want to show is this thing called, there's a couple of new tools that are available for diagnosing your production running applications. And they're called .NET counters, .NET trace, and .NET dump. So basically counters does like, you know, you have performance counters on Windows, right? But that only works on Windows. And .NET Core is a cross-platform platform for building applications. So how we're going to do this on Linux, how we're going to do this on Mac, right? So there's a couple of tools in that area that allow you to basically do that. And the same goes for .NET Trace, which basically creates like a profile of your application, so you can see what's taking a lot of time inside of your application. And with .NET Dump, we can actually go and do a dump of our memory, and then we can explore all the objects that are in memory and see what's happening there. So this is all nice, but I wanted to really show you what these tools can do. And to do that, I want to basically take you through two scenarios, which is an app that's leaking memory and how we can actually diagnose what's going on and why it's keeping things alive when it shouldn't. And the other thing is when an app is actually running slowly, so it's taking a long time and we don't exactly know what's going on, so we might want to do a profile and see what's going on within our application. So I'm gonna show you that. Now there's one important thing to note about these demos, which I'm gonna go into in a second. So these new set of tools require changes to the runtime as well, because the counters that I talked about earlier, they need to be exposed somehow, they need to be available. So these tools only work with .NET Core 3.0, and that's in preview right now. And as I said before, I didn't want to install preview bits on my production laptop because I'm actually doing production work and I didn't want to mess with all kinds of preview things. So then the question was how I'm going to do this demo because I need to have .NET Core 3.0 installed. And what I did to do that is I've started to use a new feature in Visual Studio Code, which is called remote development. And what that does is my code is actually running inside of a container that's running on my machine, and the container actually contains .NET Core 3.0, but I'm not messing with my, production things that are, so they're isolated from my main development machine, basically. And how that works is I have this dev container folder here, and this contains a Docker file. And as you can see here, the Docker file is using the .NET Core SDK. I can zoom in a little bit more. 3.0 Preview 5. So this is the Preview 5 bits. I tried upgrading this to Preview 6 and everything broke. So I was glad I actually had this inside of a Docker container because I could easily switch back to an earlier preview. And what's nice about this is that my development environment is running on my local machine, but basically the backend for Visual Studio Code is running inside of the container. So everything that I'm doing here is actually happening inside of the container. And you can see here the shell that I have. This is a different shell than I showed you before, because this shell is actually running inside of the container as well. So this is a really awesome way, I think, for people, if you want to mess with new preview bits or stuff like that, you can really use this to make sure you're not actually wrecking your machine with the preview bits that you're installing. So I've also set this up to install those command line tools I mentioned earlier. So you need to actually install those onto your machine, or in this case, into my container. And those are .NET counters, .NET trace, and .NET dump. As you can see, these are preview versions as well. And obviously, the preview 5 versions of the tools work with the preview 5 runtime. So those need to match for now. In the future, those will probably change, but this is all preview at the moment. So with that, I'm going to show you what's going on here with this application. So this is really just a normal ASP.NET Core web API. So nothing special going on here. It's just a program CS. We have a startup CS here with all the things you normally have in an ASP.NET Core project. Although this is an ASP.NET Core 3.0 project, because it's based on the 3.0 SDK. And there's two controllers here. We have the values controller, which you get out of the box with the template. I didn't change anything there. It's just a regular controller. And then we have this diag scenario controller. This is basically an API that allows me to simulate a couple of scenarios, like the scenarios I mentioned earlier. I didn't write this myself. This is actually from a diagnostics repo based from the .NET Core team, but it's very nice for demos. So I'm going to use that. So the first thing I'm going to do is I'm going to just quickly close this, and I'm going to say .NET run. So I'm going to run that API. And remember, this API is running inside of the container, right? That's going to take a minute to start up. And in the meantime, I'm opening up another shell to the right, which is that shell is also running inside of the container. And my application is running now, so what I can do is I can use .NET counters to monitor what's going on with my application. Now to do that, I need to have the process ID for the application I want to monitor. So there's this other command called .NET trace list processes. And that will actually show me all the .NET applications that are running on my machine. I could have used like a PS. If you're familiar with Linux, you can use PS to list the processes that are running, but this will actually filter out all the processes that are actually running .NET, which is nice, so I get a shorter list. So 1822 is essentially my process that's running my application. So I'm going to go and do .NET counters, and I'm going to say monitor, and then I'm going to say -p, and I need to put in the process ID that I just had. And I need to do one other thing. I need to specify the refresh interval, so the amount of time I want to wait between updating the counters. And this is in seconds, so I'm going to say 1. It's going to take a minute, and now it's connected to my running application. And this is based on a new concept that was actually introduced in .NET Core 2.2 called the event pipe. And the event pipe basically allows external processes to connect to the pipe, and they can and the application is emitting events through that pipe, and you can read them out on the other end. And that's what's being used here. But the event pipe in 2.2 didn't do anything interesting. It was just there, and there was nothing coming through the pipe. And with 3.0, they're enabling that, so there's actually some data that's coming through the pipe. Now I need to actually run my application, right? I need to trigger something so that something's going to happen. So right now I'm using like 70 megs of memory, which is not too bad for a brand new application that just started. Now to do those requests, I have this other thing here, which is called requests.http. And this is an extension for Visual Studio Code. It's a bit like Postman, if you've ever used Postman. It allows you to exercise APIs. And this is basically the same, but it allows you to write the requests inside of a code file. And you can version control that as well and do all kinds of stuff. So that's really nice. And what's especially nice here is that this is also running inside of the container. So I don't need to do any port mapping or any stuff. It's just running inside of the container. So let's run this request here. And you can immediately see that the working set of memory is going up quite a bit. It takes a while for the response to come back. And now we're up to 338 megs, but it's not going down. So something's going on here. Something's not quite right. And the GC heap, so the garbage collector heap size, is also pretty big. So now I need to figure out, so I can see there's some memory leaking here, right? So it should go down a bit. Maybe it takes a little bit more of memory because I did a request, but it shouldn't take this much. So let's figure out what's going on here. Now what I can do is I can use another tool called .NET dump. And .NET dump allows me to basically take a memory snapshot of the running process. So I'm going to do .NET dump collect, and I need to put in the same process ID, right? So I need to put in the identifier of the process that I want to create the dump for. This is going to do a dump. It's going to take a while because it needs to write out the memory to disk. That usually takes a couple of seconds. And it's always taking longer when you're doing demos. So. And actually, I was doing this demo 2 weeks ago, and it didn't work. So I'm hoping it's going to work today. I've tried it a couple of times. I think I figure out what I need to do to make it work. But I think I'm pretty sure it's going to work today. But it's taking a long time. Let's see. There we go. It's finished. So and now we need to analyze this dump file. And to do that, I can use .NET dump again, but this time I'm going to do analyze instead of collect. And I'm going to give that core file that it created. And I'm going to do a .NET dump analyze. Now, if you've ever done WinDBG, anybody does WinDBG? The Windows debugger? A couple of people. This is really similar, except it's now running on Linux in a Docker container, which is quite awesome, if you ask me. So what I can do is I can dump basically the heap, and I want to do that in like a statistical manner. So how many objects of each type are on the heap at the moment? That's going to basically dump out all the objects that are in memory of the running process. It's no longer connected to the running process. It's just reading the dump file right now. I could kill the process and it would just work. And what we can see here is that we have a lot of strings that are in memory, which is not uncommon because a lot of applications use strings. And we have this customer class, and we have a lot of them as well. So what I can do is I can actually dump all the objects of this particular type. So I can do dump heap minus empty, and I'm going to put in this thing. This is called a method table, which basically identifies the type inside of memory. And we can see that we have a lot of them. And I'm not going to wait for it to complete because that would be kind of useless. But I'm going to take one of these memory addresses, and I'm going to say dump object. And this is basically showing me the object itself, and it's showing me the name of the type, and it's showing me where that type came from, which assembly basically that type contains, and the size of memory that this object is taking. And I can even see all the fields that it has and the other objects that it's referencing. So I think this one. This is the value, so it's keeping a string in memory, and this is the memory address of the value that it's keeping in memory. Now, the interesting question here is, why is this object being kept in memory? Because you would expect this to just, be garbage collected, because we're living in a managed world, so we don't need to manage memory, right? So, but somehow it's keeping it in memory. And to figure out what's going on, I can use another command called gcroot. And I'm going to paste in that same memory address. And what it's trying to do now is trying to figure out what other objects are referencing this object, and essentially trying to walk out all the way up to the garbage collector itself to figure out what is keeping this object in memory. And I can see here that this memory is being kept, this object is being kept in memory because it's contained in this array. That array is being contained within this generic list for some reason. And then we have this cache thing here, so the customer cache. So I'm guessing that their caching isn't quite working as we expected it would be. So there's probably an issue here. So now I can go back to my code and investigate why things are being kept in memory here. So these are some really powerful tools to help you diagnose issues with your production applications. You can run this in production if you have the tool installed and you can connect it to a running application. And I think that, given the time, I wanted to just show you one more thing. Let's quit out of here, and let's do the other scenario. And it's called, I'm going to do a .NET trace, collect for the same process ID, which I don't have anymore. Yeah, .NET trace collect. So now I'm recording a session for my application. I'm using a different API that's basically simulating high CPU usage for my application. And I'm gonna, like it's running now, I'm not getting a response back, so something's happening within my application. It's using a lot of CPU. If I use the .NET counters, I would show CPU usage to be like 25% or something. So, and I'm collecting the trace. And now I forgot one thing, which is I need to do this like so. So what I'm going to do is I'm going to write this speed scope JSON file. And this is a JSON file that I can open with an app called Speedscope, obviously. And that allows me to see what is taking time within my application. So where's my CPU being used, basically. So I did that. And now let's go to Speedscope. And this is just a web application. You go to speedscope.app. And then I'm going to go to my projects, demos, diagnostics tooling. and there should be the speedscope JSON file here. I can open that up, and let me just, apparently I cannot zoom this, I don't know why. But I can see all the threads that are here. So there's 7 threads running concurrently. And this is basically what's called a flame graph. If you've ever used the Chrome developer tools, you've probably seen something similar. And this allows you to visualize at what points in time my application is actually using the CPU. And I can then find out why is that taking so much CPU usage, right? So you need to, it's not really easy to understand at quick glance, I found out. So you need to really dive in and see what's going on, but it gives you really great insights into what your application is doing and how it's performing inside of in production. So definitely check that out if you want. You can also use another library called, or another tool called Purview, which allows you to do most of the same things, but it only runs on Windows. So if you're on a Mac or on Linux, that doesn't help you much. So with that, I think I'm out of time. I just wanted to share this last slide with a couple of resources. So definitely try out try.net and see if you can use that to create awesome documentation for your libraries. I didn't show that, but you can use .NET tools, and they're called global tools, and you can install them into your environment. They're running on top of .NET, and there's an entire list of tools that you can use, like .NET counters and .NET trace that I used in my demo just now. Those are global tools as well, and there's a whole set of other tools you can find there. I've also put the link to all the templates that are available for .NET New. So if you want to create a project with some kind of structure, you can use that. And there, I linked to the blog post introducing the diagnostics tools that I just showed you, like .NET counters, .NET trace. There's a couple of other scenarios there with demos and samples that you can use. I've also put up my demo onto GitHub, so you can see that as well. I didn't share the link. I can put the link in the slides, and you can see it later. So with that, thank you very much, and enjoy the rest of your day.